Hi everyone, welcome to my channel. This is Harika. So in today's video, I'm going to talk about LangGraph. So as a part of this particular series, I'm going to take you through right from the basics till to the advanced concepts of LangGraph. So as we go further, we will be also building the chatbots and we will also use the tools. We implement human in the loop controls as well using the LangGraph. But to just start with, first, to give you an overview of what LangGraph is, in this video, I'm going to cover about the LangGraph framework. I'll help you with the documentation, and also I will be introducing you to various terminologies that we will be using in LangGraph. Okay. Yes. To go further, let me just show you. This is a LangGraph documentation page. So you can see here, if you want to explore, you have all the details. You can see how we can build a basic chatbot, how we can add tools. This is really, really very informative documentation you can build by yourself. And it also gives the whole idea of why we are doing and what we are exactly doing after each and every step. So even if it's not clear over here, you can put this in the Claude or in the chat GPT. It will give you a step-by-step explanation. If you are a new beginner and if you wants to learn and explore without just writing the code, you can actually understand what it each line does by putting in Claude. Yes. So after that, let me just introduce you to the different terminologies that we have in the LangGraph. So, if you have explored few other frameworks like Agno or LangChain or anything as such, then this LangGraph is also one such framework. But however, it is a stateful framework. So, what I mean by stateful is, if you see, we are dealing with some things called states, nodes, edges, and graphs in LangGraph. Okay, so I will be explaining you over here through this particular graph. I'll try to put it up very simple and easily understandable. But however, to just give you an overview idea of LangGraph, so this is basically a graph kind of approach or a kind of framework. Basically this will help to customize a lot of things. So most of the other frameworks are tied up to their own LLMs, but however with LangGraph you can customize it as per your need, and also it is more reliable. It's not something the LLM has that autonomy to take what step to go further in order to decide and come up with a better result. It's not, if you observe in the LangChain, or if you have familiarity with LangChain, it's basically a step by step approach. So you tell the agent or basically what to do, like first step to go ahead and do the web scraping, and then do the chunking and do the vector database and embeddings and all of that. But however, in the land graph, the LLM will have that autonomy in order to take the decisions, which step to be executed in case of errors, what needs to be done. So all this anatomy will be given to the LLM, right? So through LangGraph, you're going to see all of that as we go further in this particular series. So I hope LangGraph is something. Uh, I hope you have got a little bit clarity of this LangGraph framework. So basically, this is a kind of framework where you can give that autonomy to the LLM in order to function by taking its own step and make the output in a better way to be presented. And also, I will talk about this graph over here. This is a main and important thing of LangGraph. So I try to put it very simple by giving a very basic small example which everybody can understand. So here, if you see, first thing you need to understand is there are certain things in LangGraph called states, then nodes and edges. We will also talk about conditional edges, but yes, let's stick to the basics at the moment. So if you see, firstly, I have a start and an end. These are the common nodes that we have, okay? And in between, we have something called add numbers. This is an another node, and multiply by 2. So if you observe here, basically we have four nodes in this whole graph. So the first is start, add numbers, multiply by 2, and end. These are the nodes. So what basically nodes are, you can consider these like a simple Python functions. So what a Python function will do, add numbers, it's going to add two numbers. Multiply by 2, it is going to multiply by 2. So the nodes or something which helps to the states to change their state from one state to another state. So let's say, for example, here I have one state where we have these different data types and data values. So if you see, I have four data values: number one, number two, sum, and final. So this state has been transformed to this state because it has come from the start node to add numbers node. Okay, so as the states transform the values as they pass between two nodes. Okay, so when, and there is one more thing called edges. So the edges are the ones which will define. So let's say, for example, you, as I mentioned, there is something called conditional edge, right? So conditional edge is, let's say it is going from A to B and A to C. There are two edges, okay? So the edge is something which will define which way to choose, right? So if you see, this is an edge. This is the only edge that we have, right? So this is the edge which defines from which node to be passing between, right? So this is an edge which passes between start and the add numbers node. And let's say, for example, I have another node, which is a conditional node, right? Sorry, conditional edge. So let's say I have something like this. Instead of from start, I can have, let me just recreate this whole thing. Okay, so here let's say I have add numbers and I have multiply by 2. Instead of multiply by 2, I will also have one more over here. Let's consider this scenario. Okay, so let's consider something like this. I have from add numbers, I have multiply by 2, and let's say there is something called divide by 2. So there are two edges in this case, which is one edge says either to go from add numbers to multiply by 2, and the another edge is between add numbers to divide by 2, right? So here we will be taking a decision based on whether it's a multiply or divide. So these are called conditional edges. Okay, so every time there is a there are two nodes, when a state passes between two nodes, it's going to transform the value. That's first thing. And edge is something which is between two nodes, which says whether to go from point A to point B or point A to point C. Those are conditional edges. And the nodes are basically like a Python functions which helps the states to transform their values. So I hope I kept this concept clear to you. If you have further questions, do let me know in the comments. And now we are going to see how we can implement it using a Python workflow. Okay, so now let's go ahead and see how we can implement this. So I've actually written a small piece of code over here just to explain you the concept of this thing, what we have seen in the graph just now. And I will be explaining you how we have implemented this whole thing. So parallelly, you can try it out in your PyCharm or in your Jupyter notebook, so you'll be able to understand and also recreate the whole thing at your side. Okay, so as I've mentioned, first and the foremost thing that we are doing over here is the state, right? So the first thing is state. So basically we have to define the state first, right? In order to define, what we are doing is we are defining it as a math state, and we are providing it as typed dict. So basically what this dict will do is it creates a dictionary, and this uses this actually helps in a way that it's gonna have the data type and the data value of it. So we are telling that this state contains, these are the variables that it has, and these are the various data types, right? So number one is an integer, number two is an integer. So it expects the input in that way. Okay. And now later we have something called, as I told you, first state, and then we are going for the nodes, right? So as I told you, nodes are basically Python functions, right? So here, for example, what we are doing in this add node, this is an add node, right? So when we are going to add node, we are adding number one and number two, correct? So now let's go ahead and see what we have defined in this Python function or in this node basically. So we are adding. So when we are adding, we have to pass. Okay, let's correlate here. Okay, so when we are adding here, we are passing the state into this particular node, and we are also getting output as a state, correct? So when we do something in this particular node, the input is this and the output is this, correct? So that's what we are defining over here. So we are telling the input for this is a state, and the state is math state, and the output is also a math state, correct? But the value will be transformed after we pass it over or do the operation on that particular thing, right? So now the result will be number one and the number two from this particular state. We are adding both of them, right? That's it, and we are printing it for our easy to understand in order to showcase what is the output. And then we are providing the output in a we are providing this whole thing in a result. We are adding this whole thing and we are keeping in a result, and the same thing we are adding and keeping in the sum result. So if you see here, the match state has some result, so the sum result will be passed into this particular variable, right? And we are returning that particular thing into a state, because we already defined here the output is a state. Similar to that, we are doing multiply by 2. For this also, input is the state and the output is the state, correct? And what we are doing, we are multiplying it with 2, and we are adding that result into the final result variable inside the state, and we are returning it. Perfect. So now we have executed, or we have defined the two nodes, but we also have to add them into our nodes. So how do we do that is basically, so let's see over here, there's some syntax that there are some imports that we are doing. So whenever you're trying to build a graph, so basically we have defined everything. Now we have to define build the graph, right? So in order to build the graph, so what we're doing here, from LangGraph we are importing state graph, and as I told you, we have basically by default two nodes. What are those two nodes? Start node and the end node, correct? So we are not defining anything about start or end because there are default nodes. So we are having those two nodes as well, and we are using this particular syntax because we are building a state graph from the state which is math state, right? So I think it's easily understandable. And then in this graph, we are adding two nodes. What are the two customized nodes that we've created? One is add numbers and the other one is multiply by 2. And we are also adding edges. So if you see here, we have, apart from start and end, we have two nodes, add and multiply by 2. And we have the edges. What are the edges here? If you see, the edge is, the first one is we are starting from the start node and we are going to add numbers, and from add numbers to multiply by 2, and from multiply by 2 to end, correct? So these are the edges. So if you see, you're adding the edges. Start to add to multiply, multiply by 2 to end. Correct? That's it. And we are compiling it. So that's till here we have built the graph, but now we wanted to display it. So just go through the syntax. So we are importing the image and the display, and from there we are just viewing it. In order to display it, we are using this particular syntax. That's it. So once after you run this whole thing, you should be able to see this graph. This is a graph that we've built it. It is coming from a start and then it's going to end. In between, we have two nodes, add number and multiply by 2. And these are all the edges which defines the graph, like the direction of the graph, right? So yeah. And then here, if you see the result, basically, we are passing two numbers as input and we are getting two as output. So what are those two? Sum and the final. So after adding, we have 300. After multiplying, we have 600. That's it. I hope this example is clear to all of you. If at all you have any questions, or if you want me to explain anything on this particular concept, do let me know in the comments. I am more than happy to go further and explain any of the scenario that you have questions or doubts with. So thank you so much for watching. I'll see you with one more informative video next time. Till then, stay tuned.